Everything you were taught about the moon is incomplete. Not wrong exactly, just incomplete in ways that should unsettle you. Because the more scientists study that silver disk hanging over your head every night, the more they realize it is stranger, older, more violent, and more alive than anyone previously understood. It has a solid heart beating at its center. It is slowly pulling away from us. Its surface is painted with glowing swirls that defy explanation. And without it, without that single improbable rock, the Earth as you know it would not exist. This is what we actually know. About 4.5 billion years ago, the solar system was a war zone. Planets were still assembling themselves from the chaos of gas and dust left over from the sun's formation, and collisions between enormous bodies were not rare events, they were Tuesday. In that environment, a protoplanet, roughly the size of Mars, was on a collision course with a young Earth. Scientists call it Theia, and what happened next may be the single most consequential event in the history of our planet. The collision was not slow, it was not gradual. New supercomputer simulations published in 2022 reveal that the moon may have formed in a matter of hours, not millions of years, hours. When Theia struck the proto-Earth at a colossal, glancing angle, the force was so catastrophic that material from both bodies was blasted directly into orbit in a single violent eruption. Within a geological heartbeat, that debris began clumping together under its own gravity, and the moon was born. But here is where it gets strange. The moon and Earth share almost identical isotopic fingerprints, the same chemical ratios, the same atomic signatures, as if they were made from the same batch of material. That should not be possible if Theia was a completely separate planet from the outer solar system. Recent research, published in the journal Science, suggests Theia may have actually formed in the inner solar system, close to Earth, possibly even slightly closer to the Sun, which means that when it hit, it essentially merged with Earth rather than just splashing off it. The moon is not a piece of Theia. The moon is a piece of us. That thought alone should give you pause. Now fast forward 4.5 billion years. The moon is still with us, but it is not sitting still. Every single year, the moon drifts approximately 1.5 inches farther from Earth. That number sounds trivial. Across a distance of 239,000 miles, it is almost nothing. But zoom out across geologic time, and the picture is dramatic. When the moon first formed, it was catastrophically close. Some estimates place it as near as 14,000 miles from Earth's surface. The planet above you would have filled most of the sky. Tidal forces back then were not gentle coastal rhythms. They were violent surges, hundreds of feet tall, reshaping coastlines that did not yet have anything living on them. And because the moon was closer, Earth spun faster. Days were shorter, far shorter. Around 1.4 billion years ago, a single day on Earth lasted roughly 19 hours. Scientists confirmed this by analyzing ancient rock layers, sediment deposits that record the rhythms of the tides the way tree rings record seasons. The moon's gravity was stealing Earth's rotational energy, transferring it into the moon's orbit, pushing it slowly outward while our spin gradually slowed down. That process is still happening. Right now, today, Earth's day is getting longer at a rate of about 1.7 milliseconds every century. You will never notice it. Your great-great-grandchildren will not notice it. But stretch that across billions of years, and eventually, in the far distant future, an Earth day will stretch to 25 hours. The moon will appear smaller in the sky. Tides will weaken. The relationship between Earth and its only natural satellite will become quieter, more distant, like two old friends who have simply drifted apart. But do not mistake that distance for insignificance. The moon is not just a pretty light in the night sky. It is an anchor. Without it, Earth would tilt unpredictably on its axis. Not the stable 23.5 degrees it maintains today, but wild swings anywhere from nearly upright to tilted nearly 90 degrees sideways. Mars gives us the clearest warning. Mars has only two tiny, irregular moons. Over billions of years, its axial tilt has swung between 10 degrees and 60 degrees. Those swings caused catastrophic climate shifts that many scientists believe played a direct role in stripping Mars of its thick atmosphere and liquid oceans. Mars may have once been a living world. Now it is a frozen desert. Earth has been spared that fate specifically because of the moon. The moon's gravitational influence keeps our tilt locked in place, giving Earth stable seasons, predictable climate bands, and the kind of environmental consistency that allowed single-celled organisms to slowly, over billions of years, evolve into everything alive on this planet today. Every form of life that has ever existed on Earth owes its existence, in some indirect but very real way, to that collision 4.5 billion years ago. Now here is something that was only confirmed in 2023, and it is remarkable. For decades, scientists debated whether the moon had a solid inner core or a completely molten interior. The moon no longer has an active global magnetic field, so inferring its deep interior was enormously difficult. Then in May 2023, researchers from France published a study in the journal Nature that settled the argument. Using geophysical modeling and new seismic data, they confirmed that the moon has a solid inner core, an iron-rich ball roughly 160 miles across, sitting at the very center of the moon, surrounded by a molten outer core with a radius of about 225 miles. The moon has a heart, a solid iron heart, just like Earth, and around that heart, something else was happening. The new study also found evidence of what scientists call lunar mantle overturn, a slow ancient process in which dense material deep inside the moon sank toward the core while lighter material rose toward the surface. This overturning would have released enormous heat, which helps explain a mystery that has puzzled scientists for a long time. How did the moon ever generate a magnetic field strong enough to magnetize rocks? Because the rocks Apollo astronauts brought back from the moon's surface are magnetic, some of them more strongly magnetized than equivalent rocks on Earth. That implied a past magnetic field of remarkable intensity. The mantle overturn may be the answer. The sinking of dense titanium-rich material called ilmenite toward the core created temperature differences that drove convection in the liquid outer core, and convection is what generates a magnetic dynamo. For a brief window in lunar history, the moon had a powerful magnetic field. Then it faded. The dynamo shut down, and it left behind clues on the surface that still confuse scientists today. Those clues are the swirls. Scattered across the moon's surface are some of the strangest geological features in the entire solar system. Bright, sweeping formations that look almost painted on, curling and twisting for hundreds of miles across the dark volcanic plains. The most famous of them is called Reiner Gamma, a glowing figure-8 pattern on the ocean of storms, visible to backyard telescopes near a full moon. It casts no shadow, it has no elevation, it is not a mountain range or a valley, it has the same composition as everything around it, it is simply brighter, impossibly inexplicably brighter. And scientists have been arguing about why for decades. The leading explanation is magnetic. In regions where these swirls appear, the moon's ancient magnetic field left behind concentrated remnants, pockets of crustal magnetism that generate their own tiny magnetic bubbles. Those bubbles deflect the solar wind, the constant stream of charged particles blasting off the sun. The areas protected by these magnetic shields stay bright because the solar wind cannot weather them. The surrounding rock gets battered and darkens over time. The swirls remain untouched. But that just pushes the mystery back one step. Why is the magnetism concentrated in those patterns? Why those shapes? Some researchers point to cometary impacts, comets striking the surface and simultaneously generating electrical currents and magnetic fields that stamped their signature into the rock. Others say it is the echo of ancient underground magma movements, ilmenite-rich flows cooling and magnetizing in twisted paths beneath the surface. A NASA mission called Lunar Vertex is being planned specifically to land inside one of these magnetic anomalies and take measurements from the ground. Right now, we simply do not know what made them. The moon keeps its secrets well. Here is another one. The moon is shrinking. As its interior slowly cools over billions of years, the moon contracts. Its radius has decreased by more than 150 feet over recent geological history. That sounds like a minor change. On a body 2,159 miles across, it is essentially nothing. But the moon's crust is rigid and brittle, and when the interior shrinks, the surface does not simply fold. It breaks. Thrust faults crack open across the surface, cliffs called lobate scarps where one section of crust has been pushed up over another, like a wrinkle on drying skin. Scientists have identified thousands of these scarps from orbital imagery, and those faults are active. Data from Apollo seismometers, reanalyzed in recent years, reveals that some moonquakes reach magnitude 5 on the Richter scale and last for more than 10 minutes. On Earth, a 5.0 earthquake is serious. It damages buildings, knocks people off their feet. On the moon, which has no atmosphere to dampen seismic waves, the shaking can persist for far longer than any earthquake of equivalent magnitude. In 2025, new analysis of Apollo seismic data found that moonquakes, not meteoroid impacts, are responsible for reshaping terrain near the Apollo 17 landing site. An active fault nearby has been generating quakes for millions of years. Scientists are now warning that future lunar bases need to avoid building near these scarps. The moon is not a dead rock, it is a geologically active world, slowly wrinkling and cracking from the inside out, and it holds water. In 2024, researchers analyzing data from NASA's Lunar Reconnaissance Orbiter confirmed that ice deposits in the moon's permanently shadowed craters extend far more widely than previously understood, reaching at least to 77 degrees south latitude. These craters at the lunar poles never receive sunlight. Temperatures there drop to minus 325 degrees Fahrenheit, making them some of the coldest places in the entire solar system. Water ice delivered by comets and asteroids billions of years ago has simply sat there, frozen and preserved, waiting. The ice is not an ocean. It is not even a lake. It is mixed into the lunar soil in scattered deposits. Some pure, some diluted. But it is there, in usable quantities potentially. In February 2025, NASA launched the Ice Mining Experiment 1 aboard the Prime 1 mission to begin testing whether that water can actually be extracted. Because if it can, it changes everything about how humanity plans to live and work on the moon. Water can be split into hydrogen and oxygen, rocket propellant. The moon's south pole could become a fuel depot for the entire inner solar system. And in 2024, China's Chang'e 6 mission returned something no human had ever held before: rock samples from the moon's far side. The far side never faces Earth. It is geologically different in ways we still do not fully understand. The samples revealed basalt volcanic rock that formed 2.8 billion years ago, meaning the far side was still volcanically active long after most models said it should have gone cold. And one fragment was dated to 4.2 billion years ago, the oldest known sample of a specific type of lunar rock called Crep basalt. The far side is not simply the back of the moon. It is a different geological world, and we are only just beginning to read its story. Every mission, every sample, every analysis of ancient seismic data from Apollo, every new model of the lunar interior, they all point to the same conclusion. The moon is not a passive bystander in Earth's history. It is a co-author. It shaped our days, our seasons, our tides, our climate. It stabilized the conditions under which life could evolve. It was born from the most violent moment in our planet's history, and it has been slowly, steadily moving away from us ever since, taking with it a little bit of Earth's rotational energy with every passing year. And it still holds mysteries that no probe, no telescope, no model has yet fully explained. Swirls on the surface that look painted by an invisible hand. Magnetic signatures from a dynamo that died billions of years ago. A solid iron heart confirmed only 2 years ago. Craters in permanent darkness holding water that has not seen sunlight since before complex life existed on Earth. The moon is not what we thought. It never was. So here is what I want you to sit with. If this is what we know after 50 years of study, after Apollo, after decades of orbital missions, after supercomputer simulations and returned samples from the far side, what else is still out there, waiting to be found? What is the moon hiding that we have not even thought to look for yet? Drop your answer in the comments, because I genuinely want to know what you think we are still missing. If this changed how you see that silver disk in the sky, hit that like button and share this with someone who still thinks the moon is just a rock, because they need to see this. And make sure you are subscribed, because next time we are going somewhere even further out, somewhere the sun's light barely reaches, where the rules of the solar system start to break down in ways nobody expected. That story is coming soon, do not miss it.